Start recording. Hello, everyone, and welcome to Handmade Hero, the show where we code a complete game live on stream. Before we get back to game coding, today we've got some announcements to make for folks who you may be just joining or not in the know. First things first, the Handmade Network site has launched, and it is not actually like a kind of an official launch yet. They are it's more like a public beta. They said they are not going to be necessarily doing. I think they called it a soft launch. So they're still taking feedback and collecting bug reports and that sort of stuff. But it's accessible to the public now. So if you want to check it out, you can. And that is just at Handmade Network. This is the site, and there's a Handmade Hero page on it. The reason for the Handmade Hero page on it is because it is now the place where the forums are hosted. And they're a lot nicer than the old forums. And by nicer, I mostly just mean that they are not infinitely slow. Like, the old forums, I don't know if you remember, are just incredibly, incredibly slow to use. And they were in this nasty Joomla craziness. And so it's exactly the same forums that you're used to. They're at hero.handmade.network. And that's got like the sort of landing page and that sort of stuff, and also the forums page. And there's a specific subsection if you just want the forums. The link on the homepage will now go here when you click on forums. Your login should still work. So the old you shouldn't have to make a new account. You should still have, whoever you are, username will still work here. And when you log in, you can just put in your old username and credentials, and it should just work. So you shouldn't have to do really anything in particular. You'll just end up with new forums. And by default, just a few things are listed on the main page, and then when you click on the more, you get the full set of stuff. Again, still, it's not fully launched yet. They're still, they said they didn't want to publicize it too widely, but they did say it was okay to announce it, and the forums have been moved over to it, so people who want to use the forums have to go here now. The old forums are no longer accessible in any way. So check that out, and that is the news. That is the news. So that's about it for business, I think. Other than that, I did take the opportunity to sort of clean up some of these things. The Twitch page now has some cleaned up stuff at the underneath it. The schedule bot and the past episodes, I sort of changed the schedule bot wording in the past episodes now. Instead of going to the YouTube, just goes straight to the episode guide, which again is also, it's exactly the same as it was before. It's now hosted under the Handmade Network placement as well. So, if you come in here, you'll get the exact same stuff you were used to get. But it's just hosted at the new location. So nobody should really have to change anything they're doing. Just hopefully everything's a little bit better now, because it's out of the sort of janky old way that it was being done, and it's now on a server that's running much more smoothly and gets rid of a lot of the cruft of the old forums. So that's it. If anyone has any questions about that stuff or feedback, you can go, I think, anywhere on here. Like, I don't know super much how to use the site on Handmade Network, but I think at the bottom of every page, I'm not really sure. Yeah, at the bottom of every page, of course, it's behind my head. There's a contact thing here, or you can just put contact after the URL. If you look here, there's information about who to contact if you have a problem with the site that isn't working the way it used to or something, and you're trying to get to something. It comes in here. At the moment, I have been told that there is a holdup with, as far as Handmade Hero is concerned. Right now, there's only the forums episode guide. There's a resources page that's missing, and a thanks page that are missing. Those are supposed to be imported sometime soon, so hopefully by the end of the week those will be back. Those are not super important pages at the moment. Like, they're not like the forums where they get used every day, but they are pretty important, so they'll be back. They're not, they weren't deleted, but they're not here yet. I think that's everything. If it's not everything, you can ask the guys in chat. Most of the people who are responsible for this site are on the chat right now. So you can ask them about it and or congratulate them for getting everything working smoothly. I already was playing around with the forums, and they're quite a bit nicer. Like I said, it's kind of nice to just be able to click through them and not have to wait. At least on my machines, it was always, you'd click and you'd wait forever for it to load up one of these responses. And I think that's just because Joomla is real bad. Anyway, that's all there is to say about that. So let's go ahead and get started here. Today is day 272. If you would like to follow along at home, you want to use day 271 source code, and that is the state of the source code that I am going to be using today. So if we look at where we left off, I had just started programming some stuff for the main character in the game, because we have most of the engine stuff that we wanted to write written, and so I was starting to play around with the main character. And essentially what I want to do for the main character is there's a little bit of a kind of a strange aspect to his motion. It is not that similar to the way most characters move. In fact, the exact design that I have for it, which we're in the process of implementing now, is I don't think I've ever actually seen a game use this method of controlling the character. So it's going to be a little unusual, and it's going to take us some tuning to get it to feel right as well, because it's kind of a new sort of a thing. But that's okay, that's what game programming is about. So as you can see, unlike before, the head and the body are now dissociated, which of course is very disturbing for this poor little fellow. That is not the intent in the long run. That is just the way that I was choosing to start developing how he moved. And the reason for this is because the bottom, like the part of the person, of the hero that stands on the ground, is going to lock to a particular location on the screen. Now, it doesn't actually have to be a grid. We've created a grid here because I think a lot of the screens will want to be grid-like. So it is going to be oftentimes grid-like, but we don't actually require it to be grid-like. We may use some very non-grid or sort of layouts of things in the future, but what they will all have in common, and you can see this based on the little squares, the little yellowish squares in the middle there, the sort of orange squares, that the body snaps to. What you will notice about these is that it always has to go and be on one of those points. That's where the body has to be. And so what I want to have happen, and what we're trying to shoot for now, is I want the body to always be locked to one of those. And when I move the head, what I want to do is for him to just lean. So what we're going to try and do is make it so the body part of the hero just leans, left or leans right. And then only when the head has sort of gotten to the midpoint, right? So when I'm here, then the body actually sort of will jump, right? And I mean that literally, not in the figurative sense of it's teleporting from one place to another in code. I mean literally jump, like the character will like push off the ground and go towards the other one. So it'll kind of hop. And so you can move the head around freely, and the head will be movable, not maybe exactly like I'm moving it now, but kind of similar. Like, it will feel mostly like this to move the character around. The only difference will be if you let go of the motion, if I'm not moving, it'll snap back to the neck, right? And so what we really need to do now is I need to essentially take that, well, there's a couple things we need to do now. One is I have to actually write some real code. This was kind of just makeshift code. I need to write some real code that tries to actually keep the body on a particular square. So that has to be done. And I also need to write some code that will stretch the body, like do that sort of rotation and scale, so that the body will attach to the head, because I don't want it to appear like the head is floating at all. I want it to feel like the head is solidly attached to the body. So we need to do that. And then I need to start working on the code for doing that animation of sort of jumping between different locations. So a lot of work there. And I think it'll take us several days, because we're only doing an hour a day. I think it'll take us several days to get this right. And since this is going to be the main way that you interact with the game is this kind of motion. We really want this to feel good and look good, so we want to get a good first pass here. It's probably not going to be the final one because, you know, we'll probably tweak it continuously throughout the entire project. But we want something that feels good to us now, so that we know before going any further with this design, we know that that part is stable. You definitely don't want to proceed further in the code until you know that the actual act of interacting with the character is, you know, enjoyable, right? That would be bad if it felt lousy to interact with the character. And by feel lousy, of course, I mean to me, because it's my game. Obviously, not everyone has the same opinions about how character motion should feel. Of course, everyone thinks that they have the only right opinion about how character motion should feel, but those people are unfortunately misguided and probably products of a broken childhood. So it's okay, you know. They can get therapy. It's not the end of the world. And the rest of us can just acknowledge the fact that we have different opinions about how character motion should work. So let's go in here to Handmade code, and let's go take a look at the sort of beginnings of the code that I put in there. It was in world mode.cpp, and we've got sort of the two different things here. We've got the hero head, and here, you know, you can kind of see the code that I wrote here. Here is sorry, that's the motion code for it. I don't actually need that. Here we go. Let's see here. Hero body, and here we go. So what I was doing here is, again, just sort of prototyping out this code. I essentially made it so that the body just takes a look at wherever the head is. It searches for the closest point that it could stand on to the head, and it moves towards that. Now, if it's already on that point, obviously it'll just kind of stay on it. But if it's a different point, it'll move toward it. And it moves toward it using the standard movement code that we had worked on already. So the problem with this, there's a number of problems with this, but the biggest problem with this is it's a little too analog for my taste in this circumstance, right? What's happening right now is that body, and I can sort of draw this out for you, what I'm a little nervous about, and what I will, you know, sort of try to correct here. So what I'm a little nervous about is, you know, I've got the body here. You know, here's the head, here's the body, and the body is standing on a particular point. Now, what I want to do is I want to acknowledge the fact that there's essentially two phases here. Because right now we only have one phase, right? There's only movement. There's just, where am I trying to go, right? We just have a target and we have a position. And we're just always going to move towards that, right? I mean, that's the way this code, you can just read this code and you can see that that's what it does. It basically says like, okay, I'm just trying to go here. And the reason why it sort of stops on a point is because if that target happens to be coincident with the point, then there's really no motion. And so, yeah, you know, we get a situation like that where it comes to basic rest on the thing, but it's sloppy and it overshoots. And it doesn't even really know the difference at this point. It doesn't really have a conception of being in those modes. The only thing I could really do is if I wanted to, I could check an epsilon and say, how close am I to the point? If I'm close enough, then call it a day, right? But the code, you know, is just not aware of that aspect of it at the moment. So I think the first thing I would like to do is increase that sort of state space to basically have stand and movement as two separate modes. And people asked one person asked me the other day to explain, we didn't get to it, but in the questions, they had asked me to explain finite state machines. And, you know, we can try to do this at some point. Finite state machines are kind of, they're one of those sort of glorified terms that isn't really super useful because makes it sound like there's a formalism when really there's oftentimes not a formalism, and oftentimes you really don't want a formalism. If you go read something like compiler literature, you'll see a very formal definition of things such as a finite state machine. Usually there's sort of these, there's two aspects of these, again, with the formalism, and maybe we'll explain these someday, but I'm not going to really talk about them today. There's deterministic and non-deterministic ones, and there's a lot of stuff in here that gets formalized for purposes that are probably quite useful in CS, but are really not very useful in programming. Like, if what you're actually trying to do is get stuff accomplished, I don't find these are ever useful to really think about. And the reason for that is because they approach the problem kind of the reverse direction from what you actually are trying to do. I think of FSMs a lot like object-oriented programming. They are basically a way of trying to pretend that the notion of like what state you're in is somehow this like pure, primal, important thing, and everything else has to like come out of this concept of the state that you are in. And that's just hogwash. It's not actually true. And so again, while finite state machines as a formalism for certain types of analysis and in studying things and all this sort of stuff is probably quite useful, in actual coding it tends to lead people down the OOP trail, I feel like. The same sorts of stuff that's problematic about thinking that objects are primal and objects are very important and you should start with the objects. Same sort of thing happens to people when they go down the finite state machine route. They start thinking that states are this important thing and somehow it's different. Really, it doesn't matter at all, right? Conceptually speaking, you may want to start thinking of things in terms of having some states when you're at the part of your program when it's clear that there are some concrete different states. But really there's a lot of fluidity between these two things, and oftentimes you don't really want to think about things being entirely in one state or another. And so you want to let the concept of states come out of the natural coding process. And you don't want to like clamp this concept of a finite state machine down onto the code, because it has all of those same negative effects that object-oriented programming does. That doesn't mean you won't get to something that has finite state machine-like elements in it, and in fact you would argue, I think quite convincingly, that there's plenty of parts of Handmade Hero that already look finite state machine-like. And that's because in the course of ordinary programming you oftentimes will end up with an enum that says what of a couple different ways something could work it should be working right now, and inside the switch statement that switches on those enums will be what's the rule for transitioning to setting the enum to a different value. That in and of itself is definitely a finite state machine. And so again, not a bad thing, just a bad way of approaching a problem. You usually want to come at it the other way around, and then you'll just find one day, oh, looks like there's some finite state machines in here. And pretty much any program of any complexity will have some things in it that look like, or technically even are directly, a finite state machine. It's how computing works. So it's not surprising. So what I want to do is sort of increase the stateness of this and say that when I'm moving around, the body is going to be in a particular state, which is stationary. And when it is in a state that's stationary, no matter what I do with the head, the body's going to stay where it is. And so to get this sort of started is very simple, obviously. I can just go to the sim entity. Oops, sorry. It's not in sim entity, it's in sim region. We'll probably have to start breaking these files up a little bit as we sort of get going with them, but for the moment, fine. So in here, I'm just going to do like a sim movement mode or something like this. And I'm just going to say, okay, there's a movement mode, which is like body standing or something like this, or planted. And then there's a sim movement hopping. And I'm just going to have those two modes right now. And so when I am talking about the body, it can either be planted, which means it's like on the ground specifically, or it can be hopping, which means it's going to like move from one place to another, right? So here's my movement mode. And then in here, when we get to something like hero body, I can switch on what the movement mode is, and I can do whatever I want. So if I say, okay, what's my movement mode? I can say, all right, if the movement mode is sim movement, you know what, that should probably, instead of sim mode, it's probably movement mode. So if my movement mode is planted, then I should not be able to do anything at the moment. And if my movement mode is hopping, then I can, you know, have it happen. So I'm going to go ahead and take this code. Well, I suppose I should also say that, you know, probably you've got to have the head. If the head is gone, none of this is going to happen. But I'm going to take the exact same stuff I did before. I'm going to say that in hopping mode for now, even though it's not what I actually want, for now, what it'll do when it hops is it'll use this sort of this chasing behavior that we already implemented, and when we're planted, we won't. Okay. So now what should happen if everything is working correctly, that movement mode is going to be initialized to 0 when this thing is cleared. And so when I actually try to run this game, when I move the head, nothing should happen, right? It should be stationary. And the reason for that is because I can't actually ever get out of that mode. There's no way to trigger a transition to the hopping mode. And so what I want to do here is write some kind of an if statement inside that planted mode that's like, well, what has to happen to make me start hopping, right? What will make that hop start occurring? And so I may want to keep this code. For example, I may want to say, let's take a look at what the closest thing is, right? And so I'm going to move that code outside. We'll say every time we'll take a look. But we just won't actually do any movement unless we're in the hopping mode. So in here, what I could say is, well, okay, wherever the head is, I'm going to say that if the closest point to the head is not the same as the closest point to the body, then that's when I would start moving, let's say, right? I guess the other thing I could do is say, well, the distance of the point from where I am has to be greater than something. Who knows, right? But I can easily do that. So if I said, here's my closest distance squared, I could say that the closest distance squared, well, that's going to be the head. So yeah, I need to basically say, how far is the point to me? So here's the closest P. So I'm going to say, all right, the body delta, I guess. The body delta is if I was going to go from where I am now to where I want to be. That's the delta between, you know, that I'm going to have to move. And so how far is that, right? So this is the body distance. And that's just going to be the length squared. Again, I'm just avoiding a square root, although they're not really that expensive anymore. I'm old enough that I always think of square roots as scary. Like, oh my god, don't take a square root. They're not even scary anymore. You can go ahead and square root stuff all day long. Sines and cosines still aren't great, but square root, nobody cares about square root at all anymore. Even sine and cosines aren't really a big deal anymore. Compared to memory accesses, nobody cares. Anyway, body distance is going to be a length squared of the body delta. And so what I want to do here is say, if that body distance is greater than some amount that I'm going to call my tolerance. So whatever my tolerance is, like let's say, you know, 1/100th of a meter. If it's more than that, then I'm going to switch into the other movement mode. So I'm going to switch my movement mode to movement mode hopping. And I'm going to do the exact same thing here. When I'm in movement mode hopping, I'm going to say that my transition out of hopping is just going to be when the body distance is underneath that tolerance. Again, this is just for now. This is just to have something that does whatever it's going to do. So that doesn't look like it's stopping. What did I do? Ah. So it helps if you actually type the right transition in. So now what should happen is when I move, it should actually stop, or not. And you know what I might do here, actually? I feel like I should be able to take the body. Can I click on the body? I wonder why I can't click on the body. Do we know why I can't click on the body? Because it's not like I can easily make it so that we wouldn't get at it, but I'm only getting, like, I can never actually click on that. We're gonna have to figure out at some point how to make sure we can click on all our entities, because right now we're not really able to view stuff for entities that we can't highlight, and there's a lot of entities we can't highlight, right? Which is super annoying. Like, I can click on these guys, but I can't click on the one that I want to click on, if that makes sense. So that's unfortunate. What was I about to say? Oh, right. So I want to see why this guy never actually gets out of his hopping mode, right? Because you can see here, when I'm taking the body distance from wherever the closest point is, I would have expected to be able to get my movement mode back to planted at some point, right? And at the moment, it does not seem to be the case, and I'm not sure why. So I'm going to go ahead and take a look and see what's happening there. It may be that the way that we've written our movement code is such that the drag is insufficient for it, and if so, the stuff we're going to do in a minute will take care of that entirely. But yeah, so I guess it looks like we never get here. Do we? Okay, there we go. Let's come back around. You know what I think? I think I know what it is. Or maybe I don't. I don't know. We'll see. Do we know why this is still happening here? Some of this... Why is the entity collision getting set to null collision? Do we know why that's happening still? I will say that I'm a little surprised at that. I don't know what that's still doing there. Let's get rid of that. Just because that is not supposed to be there. Okay. So I need to figure out, again, why I'm not getting the stopping here when I switch to the planted mode. And what I want to figure out is what is causing me to move out of it. So let's again go ahead here and say I'm going to set both breakpoints. So if we get to either of these now, it will happen. I want these to both be set. So it looks like it's just because we oscillate in between them. And this is probably because this is a bit sloppy. Like, I mean, you could imagine you want the tolerance, for example, of this guy. Well, okay. Here's another thing I could do. Even with this tight of tolerance, I could do something like this. I could set the velocity of the character to 0 immediately upon hitting it, so he doesn't carry forward. Because that, now that I think about it, I forgot that we do physical simulation on the movement of the character, so probably what actually happened there is, hey, we got close enough, but we don't have any acceleration anymore. If we stop accelerating, we'll keep our velocity, and our drag will be set to nothing, because our drag will be 0, which means we'll just glide until we're outside the point and we'll toggle back. So we need to, if we're going to stop, actually stop, if that makes sense. So actually, now that I think about it, that was probably, yeah, that was the entirety of it. So now you can see that we, when we actually get to it, we do stop. It's still, because of the way we set it up, it still has the overshoot problem, but there you go. So now that I have that, what I want to do is I want to move to a more animation style movement of that, because this is a very discrete thing. So I want to make it so that it's I want to make it so that the control of it is not just a chasing vector like that. Like I think I don't really want to, I don't want to use acceleration, velocity kinds of stuff for it. I think I want to use something a little more procedural potentially. And that may be a mistake, I'm not sure, but I think that's what I want. And The only reason that I think it might be a mistake, and perhaps you might also say the reason why I can't tell if it's a mistake automatically, is because I'm not sure exactly what should be happening feel-wise, and I just kind of have to play with it. What I've got is a situation where there are two places where the player can be standing, right, as per the design of the game, which again, perspective on the design of this game is there is a design and we are implementing it, because this is a stream about game programming, and so the idea is that if you were in a real environment where you're actually programming a game, you aren't the game designer, you have been told that this is how something's supposed to implement, you're supposed to implement this thing, but you need to be able to polish it and tune it properly, because obviously if you don't have those skills, you're not going to be a very good game programmer. So what we want to do is take that design which says that, okay, you need to hop from one to the other, the head is here and the player is moving the head, so we have to have something that feels good for the head control, and when it gets to, somewhere like here, we want this hop to occur. Now the problem with this is I don't really know what I want to have happen if the player, when they're playing, moves the head to, like, let's say here, and the hop begins, right? So I come up here and maybe I'm here and the head is like here by then. But then they like wail on the left button and start to move the head back. So now as this thing kind of comes up here, the head is back here now. And so now it's clear that the body should actually reverse course in its arc and come back to here, right? Let's take an even worse scenario and look from the top down. So here's from the top down. Here's one standpoint. Here's another standpoint. And here's another standpoint. Okay? The player is standing here. They move the head to here. You know what I should do is I should draw a square for the body. They move the head to here, so this square starts moving, and it gets to like here. But then the head sort of moves back over to here by the time the head gets here. And now what does the head do? And what does the body do? Because there's two ways I can write this code, and they have fairly profound implications for how the game's going to feel. One is sort of like almost like a basketball style feel, where it's like once you commit to a move with the pelvis, it has to complete. So once you get past there, once the hop starts, the hop ends here. So you can still move the head, and you can move the head back the other way, and you'll be ducking, you'll be like dodging this way essentially, but the body will move into that square, right? Whether you like it or not. That's one way to do it. The other way is you can air control out of the hop and actually come back to either here or potentially even to a different one of these. Like maybe you can even air control, if this is A and this is B and you're going from A to B, maybe you can even air control out to C in that case, right? And I don't know which of those is the best thing for this game to feel like. Certainly there's more like consequence to the concept that if you go in a direction, you have to commit, and you will go that whole direction. And you can air control the head and dodge or do other things potentially, but you're gonna touch that other square, and any gameplay implications that has, you've now committed to. That's certainly, perhaps a more interesting thing, but it may not feel good enough. It may feel too heavyweight, and it may be that the player really wants to have a forgiving enough control that they want to be able to sort of cancel out that hop so that they can sort of undo the fact that they made a hop in that direction before they actually pay whatever the cost is of stepping on that other square. And maybe there's no cost, but sometimes there might be. Like, if you imagine that's a pit or a bomb or a trap, and I'm going there and then I sort of like midair correct out of it, do I want to let them do that or don't I, right? And I don't know the answer to that question, but it has implications on how we implement it, because obviously they're going to feel a little bit different. So what I'm going to do is I'm going to implement this for now as a parabolic spline, right? So because this is about somebody who's jumping up in the air, and so when you jump up in the air, you're going to be in a gravitational arc, right? And at the risk of stating the overwhelmingly obvious, in case folks on the stream have never been to a physics class, you know, in high school or something, gravity's arc is a parabola, right? And you know, so the look of the arc that you jump when you jump into the air is a parabola. And as you know, a parabola is a function of time that is proportional to the square of the time, right? So it's going to be something that looks like this. It's an equation that looks like this. And t is not necessarily even an interpolation parameter. In this case, I'm talking about actual time, like the real time in the real world. This is what something looks like when it is in free fall. And again, this is in a vacuum. It's not subject to air drag or anything like that. So there's other terms in here if we want to start talking about other physical sort of aspects to it. But in general, the arc is going to be parabolic. Now, why is that true? And we've already covered enough on Handmade Hero actually for you to know why it's true. If you go back to the physics stuff, you can figure it out pretty easily. And so I'll just mention it here. And if you care, go back to the physics things and look at the episodes we did on basic equations of motion. And the reason is because the second derivative of what happens in time in the real world, you know, under gravity is a constant. Gravity is an acceleration, right? Gravity is something that happens in the second derivative, right? Because remember what our derivatives are. Zeroth derivative, first order, you know, we've got position, which is where we are in the world. Its first derivative is velocity, and its second derivative is acceleration, right? So the second derivative of something, acceleration, gravity is a constant in the second derivative. It's 9.8 meters per second squared, and that is what it is. That is what your acceleration will be under gravity. So if something is constant in the second derivative, when you integrate it up one time, right, it is going to be to the first power of the thing that you're of the independent variable, right? And if you integrate it up one more time, you will get it squared. So the reason things are parabolic under gravity is specifically because gravity is a constant acceleration, and acceleration is the second derivative of position. Integrate it up twice to get that position, and you will have a function proportional to the square. And that is why this is the kind of thing that we see when we're talking about an acceleration. All constant accelerations are parabolas in space. That's just how that works. That's math. So, given that I know this to be true, what I should be able to do is write directly into the motion of the character a parabolic arc that will move him from one to the other when he goes into his ballistic phase. And I will make it so that his hop time takes a certain amount of time. Again, this is part of the design of the game. I wanted to sort of explore the concept, for lack of a better term. I'm not a game designer, so you know, take it with a grain of salt, but it is my game, so I can do whatever I want. I wanted to explore the concept that you don't move the character as a unit, you move the character as two pieces, and one piece moves sort of in a more typical gamey sort of fashion where you just kind of move it and it's just kind of a sloppy thing that moves around, but the other one is very specific, and you don't get the opportunity to directly control it and tell it where it's going to be. And so that is how this character's motion works. So what I want to do is say, well, in the planted mode, then we obviously know that we don't really have anything happening as far as any differently, right? The planted mode will work exactly the same way. No movement for now, and then when we find that we need to go somewhere far away from us, then we will move to our hopping mode. Okay. So it's really only the other mode that we care about, and this is going to be a t movement variable that I have in here, and that t movement variable is going to go from, like, say 0 to 1. Okay. So what I'm going to do in here is I'm going to say that when we come in here, we know what the dt per frame is. So I'm going to go ahead and use whatever that dt per frame is. I assume we've got that here somewhere. I don't know where it actually is. Is it up here? It's just dt. Okay, so I don't even need to do that. I just need to say dt. So we have the delta time, and what I'm going to do is I'm going to take that t movement variable for the entity, and I'm going to go ahead and add it. So as time goes forwards, the t movement will increase. When I start my jump, I'm going to set my t movement variable to 0, so I know that I'm at the beginning of it. And when I find that I have reached the end, right, then I will transition out. So instead of this previous thing that we had before, instead I'm going to say, okay, I'm going to say that the t movement variable, if it is greater than or equal to 1, so I've completed my whole parabolic arc, and I'm just going to parameterize it from 0 to 1 for now, because that's usually the easiest way to parameterize stuff like this. It's easiest to think about things normalized to a range. Then I will say, okay, that's the end of it. So the movement mode switches back. Well, it's this code right here. The movement mode switches back to planted after that's done. So now this code no longer exists, and I'm not going to move the player via this at all. Instead, what I'm going to do is move them specifically to the point that I suggested. So this is the closest P, and so what I'm going to do is make a movement target, and I'm going to tell the code during that transition, hey, this is the movement target, this is where you're going. Okay? And so now the simplest thing I can do, and this is very, very easy, so I'm just going to start with it, is since I know the movement target, I should be able to make it so I can, excuse me. I should be able to make it so that I can go directly to that movement target over time using the t movement variable without using any interceding movement code. So we're just going to make a programmatic parabolic arc that we can use here. Now I'm going to start by making this, well, in fact, I may actually keep it this way. I'm gonna change it up. I'm gonna say that we keep the from as well, because that actually is going to be the easiest way to do this. There's a different way to do it that we probably will maybe want to do and probably talk about later, but for now we'll actually start here because it'll be easier to show what's going on. So movement from is always going to be the place that I started. Movement to is that point that I'm trying to get to. And then I've got this t movement variable. So if I know the t movement variable, we can go back and lean on the exact same thing I say we always can use, which is, and you know, I'll zero out the velocity here too, just because I don't actually want any possibility of getting velocity. Which is just leaning on that linear blend, right? I've got a t value that ranges from 0 to 1. I know where I'm coming from. I know where I'm going to. And so I can just lerp between those two, and that will get me my motion, and that's a starting place for my motion, right? So if I come in here and we take a look at what that lerp value is, you can see now that when I do it, it just linearly moves between those points, right? And the answer to how fast it moves is just whatever I added here. So in the t movement code, if I wanted to make this faster, which I do, you could see how slow that was. This would be kind of maddening, although perhaps interesting for a mode in the game where you accidentally swallow a bad potion and you move really slowly. You know, if I want it to move 4 times faster than that, then that's just an additional speed multiplier that gets added on there, right? And you can see that I'm just moving between these, and maybe that's the speed. I don't know what the speed is. Probably, you know, maybe a little faster even than that. So that's the t movement. Again, really, really straightforward, and you can kind of see, in fact, that looks actually pretty good already, just even at linear. So, but that's not a hop, right? And that's not a parabola. That's just lerping between the two. And so what I want to do now is I want to sort of add that arc in, right? I want to add that hop that's in there. And so the question is, well, how do I make that hop happen? How do I get that sort of that sort of combination there, right? And so what I'm going to do is I'm just going to say, well, what we need is we need the concept of of this arc. I have this point and I have this point. And that's enough to tell me the line that I should move between these. But what I need to know, right, is I need at least one other piece of information, which is how high, right? So there's like a height in here that would tell me how I was going to hop. Now, I can use a quadratic spline, a quadratic B-spline for this. and feed in this midpoint by construction or whatever, right? And that's a pretty interesting thing, and I actually have a video up on interpolation where I kind of explain how splines work and how to derive them and all that stuff. We could go through that. I'm going to show you a different way right now because I think the spline stuff will come up at other times as well. And so since we're in a situation that's fairly straightforward here, I'm just going to show you one other way you could approach this problem when I'm like, you've got some things you know and you want to, you kind of want to have some way of making these things, breaking down a problem like this. So I'm just going to kind of show you how to approach it from another angle of like breaking it apart and just give you more tools in the way you think about these things. So the first thing that I would point out about this is we kind of know, right, a bunch of things about it. At t equals 0, we know we're at that from point, right? And at t equals 1, we know we're at that destination point, right? So we know that whatever the function is that we're talking about, we know that the function, this magical thing that we want, if we plug in, well, 0 to it, right, I want it to evaluate to whatever the from was, right? So I want it to evaluate to p from. And if I'm at f1, right, when the thing is over, I want it to be p2. So I know these two things about my equation. And I just said that I know it's a parabolic arc. I want it to look like a parabolic arc. So I know that the structure of the equation can only be one thing, and that's at squared plus plus bt plus c, right? So if I know those things, and we look at this, I've got an equation, right? And I've got two things to plug into it. And so the question is, can I solve it? And the answer is, well, if you look at the structure of it here, there's actually 3 unknowns in it, right? There's A, B, and C. And unfortunately, from looking at what I've got for the information, I only got two things I know. And so I've got 2 equations and 3 unknowns. That's not enough to solve this system. You know what I mean? I simply don't have the ability to solve the system with only that. However, we already know that there's a parameter missing, which is the height. So obviously I could write another equation for the height. However, what I'm going to do first is just say, well, let's just take a look at this and see what happens when I plug these things in to this equation separately, right? So if I was to say I'm doing f of 0 equals p from, and so what that would mean is, well, okay, f of 0 into this equation means that at0, right, it's going to be a0 squared plus b0 plus c, and I say that that equals p from. Okay? Well, if you look at what happens, these two terms cancel, which means I immediately know that p from is my c term. So really, I'm not even talking about that part of the equation anymore. I just know that c equals p from. And this is so magical because this is why math is always so interesting, is because math just works. It does what when you actually investigate it, and you don't have like a math teacher scribbling stuff on a chalkboard annoying you. When you actually go and look at it, it just works. What is that saying? It's saying that like the basis for my jump, the thing that doesn't change at all on the jump, is where I start from, right? It's like it's rooting the equation at my jump off point, right? Which is exactly what you would think. It's telling you exactly what you would have intuitively thought, and that's just so satisfying, right? It's very, very nice. Okay, so then the question is, well, what about f equals 1? What happens there? So at f equals 1, then I have a times 1 squared, right, times b times 1, plus my p from, because I know that that's what that is. So now I've got this equation, right? And obviously 1 squared and 1, we know that, you know, f of 1 is a squared plus b plus p from, we know how to multiply by 1, right? And we're saying that that equals the 2. Okay? So if we were to, look at what we now know, essentially what we could say in terms of what we're trying to solve here, if we start moving things to one side, we would get another thing that looks incredibly intuitive, right? And it's this. If I subtract p from both sides, look at that term, right? That's the delta, that's where I'm trying to go, right? That's where I'm trying to go to. And so exactly as we would expect it, at the point where we have finished the jump, the sum of the other terms in our equation had better equal the delta that we had to go. Because if they didn't, we wouldn't have gotten there. So we also know that a squared plus b squared is going to equal our delta, right? That's what we know. So you can kind of see that even, I just kind of wanted to show you that before we even talk about what our final way, prescription for this is going to be. I just kind of wanted to show you how interesting it is that when you start looking at the math, you can start to see that the math is actually, the terms in the math are actually about what the diagram is, right? It's not like it's some weird set of symbols that don't mean anything. They're actually really very strongly rooted in the situation that you've created, right? Okay. So what do we do with the rest of this situation, right? What do we actually do with, oh, that's great. I don't know why this squared term is still there. There we go. That's what I actually meant to do. It's not supposed to be there. It's the 1 that's squared. And yeah, can you tell I'm not a good mathematician? Anyway, so we do know that a plus b has to equal the delta, right? And so what we need to know at this point is we need to know, if we solved for a, we would get delta minus b. If we solved for b, we would get delta minus a. So we know that whatever part we put into the squared term, the other part has to balance it out, and vice versa, right? But what we know is we have essentially two completely independent vectors. And as long as their sum is the delta, we will have a proper parabolic arc that will go from where we want to go to where we want it to end up. And so what I wanted to underscore by working this through is that you, if you're tuning a game, you don't really even have to solve equations. What you have to do sometimes is just partially solve equations. And once you now know that you can just freely make two vectors who have to sum to the delta, well, I can even just start tuning whatever that has to be, right? I know it sounds a little strange, and if you aren't used to doing this, it might be kind of weird, but let me show you what I mean in actual practice. Here's our equation, right? I'm just going to type it in over here. Right, here's hopping, okay? And previously I was computing it via lerp, right? Now I'm going to do it, I'm just going to put in the equation as we had it, right? And so we've essentially got a plus b plus p from. That's what we're doing, right? Well, more like it's a t squared plus bt plus p from, okay? So the resulting position here is going to be, a, whatever that means, we don't know yet, right? Here's our t, and in fact, I'll go ahead and pull that out into an actual t value. There's the t value. At squared plus b times t plus that from parameter. Okay? Now you can see I've literally just typed in the equation. It's just the equation. And so the question now is, what's a and what's b? Okay? Well, we know we only have to put in one of them, right? Because I just showed over here that we know that the other one has to be whatever it takes to make it equal delta. So if I want to, I can say, let's just tune the squared parameter. For our gameplay tuning, we'll just tune the squared parameter. And we'll leave the other parameter dependent on it. So we know what the delta is, right? The delta is the entity t movement to minus entity movement from. We know that that minus whatever we put in here is b, right? That completes the equation. So if I wanted to, I could start out with that just being nothing, right? If I wanted to, there's nothing there. And then everything is in this term over here, this b term, right? I could. That would just work, right? Or at least it should work. Oh, but you know what has to happen? I have to actually, I deleted the equation. Why did I do that? That's great. I'm like, hey, let's run the equation. Maybe it would help if I didn't delete the equation first. Unbelievable. All right. So there we go. Now I actually have it. So as you can see, or at least hopefully you can see, that if I was to make everything be in the linear term, so I set that t squared term to 0, what do we get? We get back lerp, right? Because if you set the squared part of the equation to 0, so there is no, right, a times t, if the a is 0 and the t squared goes away, there is no parabolic part of the equation anymore, right? It's gone. Parabolic part is gone. So if the parabolic part of the equation is gone, then everything goes into the linear part and we're back to lerp, right? And hey, what does that look like? The t parameter goes from 0 to 1. The b parameter is just the subtraction of the to and the from. That's literally going to give us lerp back. So now all we're going to do is we're just going to tune what part of the jump do we want to be parabolic. Well, hey, guess what? I probably want the height to be parabolic, right? I want it to do that, right? Unfortunately, I don't even know what we're doing with our z. We don't use z yet, do we? Yeah, we still don't use z. We got to fix that at some point here. I'll stick it in y for now, but yeah. So you can kind of see now, I guess, sorry, it goes up the screen. So now you can see that what I've done is I've put a certain amount of the hopping motion. I've placed that into right. I've placed that into the parabolic part, and so now I'm hopping as on a parabola. I guess we better not leave. We better not leave the legal zone. Sorry about that. We're not doing any collision detection anymore. I turned it off, I think. So we can hop straight. I think we can hop straight out of. Well, no, actually, how do we hop straight out? How am I getting out there? I don't really know what we're doing. We've turned off so many things, and there's so many things weird now about that. I don't even know what's going on there. But so now I've just put that part in, which means if you think about what actually happens, the other parts of the equation, right? The other parts of what I'm doing, those are not parabolic. So the motion between the 2 points is still linear, right? And it's just that vertical part that becomes parabolic. So there you go. So yeah. So there's a lot more to say about this, but I'm kind of out of time, if that makes sense. But I guess what I would say about this is just remember for now until tomorrow that concept that if you solve everything out first and then just instead of trying to get a solution to an equation that you're going to know that you're going to tune, think of it as just reducing it down to a smaller set of variables and then just tuning the variables. You can actually start with stuff that you don't even have a solution to and then just play with the values till you get the thing that you want, right? Which is what we did here. So now I will go on to the Q and the A. Oh my god! Zanbot banned the HMD bot? Are you kidding me? That's hilarious. The hopping looks so cool. Can we see a little bit more of it? Well, I don't think the hopping looks really very cool yet. I mean, the head's not even attached to the body, so it ain't great. Yeah, I don't know why we're able to select that at the moment either. I do not know. I feel like our selection, we probably have to just go look at the selection code. It's probably all messed up, right? But how did you split the head from the body? Well, they're just two separate entities at the moment. So right now we just have one entity that's the head and one entity that's the body, and it jumps around. How interesting do you think it would be to solve for the force and direction required to reach a certain height on each jump? Is it just more work than it's worth for no tangible gain? Yeah, I think so. I guess what I would say is it's not so much that there's no tangible gain in general. There is a tangible gain in general, and that would be that if we wanted to integrate it into a physics system where we were doing a lot of physics sim, then we would need to do that because we need to figure out what the force is so that that whole system works. You can't just go moving things around willy-nilly in a physics system because you need them to like collide and be able to like push back and all that stuff, right? So in a game where I was anticipating doing that sort of stuff, we might want to do that that work, right? But in this game, it's much more logic-based. It's not so much physics-based. So what we'd rather do in here is solve those sorts of things logically, if that makes sense. And that's why I'm not trying to feed it through the force part of things. I am guessing that both the familiar and the enemies will need to move similar to the hero. Is there much more you need to do to make this work with them? Yes, we will have to. We'll have to make some pathfinding that knows that it can only go through the squares and that sort of stuff. So there's going to be some things like this that happen. Can we clean up the extra head and body on the screen, or are they going to be used later on? Yeah, actually, those are still actual things. In theory, like, that one will follow you around. I don't know what this one is. I think it has something to do like with something that you could, I don't know if it was like a target or something. I'm not sure. That one will probably go away eventually, but yeah. So will these weird little plates that I have that I can shoot out for no apparent reason. Why doesn't the head just stay on top of the body? Is that a bug? No, they're two different entities, and so they move independently now, and the body just follows. And I want them to actually, I don't necessarily need them to be separate entities, so we could merge them into one entity. I think that will depend on how our entity system shakes out as we sort of actually build one, because right now we don't really have one. As we build out the entity system, we'll make a decision about whether they should be one entity, a combined entity, or whether they should be separate entities. I suspect they should be separate entities, but right now they're separate entities, and I want them to remain sort of separate like that, and all I'm really going to do is I'm going to make the body like track to where the head is so that it stretches between them. but they're gonna stay kind of independently controlled like that. Bard mode. When writing in a procedural, I'm assuming language, I sometimes end up with deeply nested code. Should this be avoided, and are there good ways to minimize this? I mean, the only real problem with nested code is that editors don't handle it right. They don't do a good job letting you work with it as easily. So that's kind of a little annoying. But otherwise, it's fine. However, if you do find that it's problematic for you, yeah, I mean, if you want to, might as well just take a chunk and move it out to a function. It's not a big deal, right? In Gennaro, this is starting to look a lot like Crypt of the Necrodancer. The design isn't really anything like Crypt of the Necrodancer, although I haven't played. I only like briefly played Crypt of the Necrodancer, so I don't know that much about it. But it's, as far as I know, really not at all related. Trapmaster, missed a lot. Are you making an engine for this game, or is that stuff just there for purely for us right now? Yeah, we did. We made all of this engine from scratch on the stream, including the renderer. You can even render in software, which is pretty cool. I forget where that is. It's in here somewhere. Yeah. We're compiled in debug mode right now. And of course, for some reason, we aren't clearing. Do we not clear in software? Or do we not clear at all? Does anyone know? Like, what the deal is with that? Handmade. Because I noticed that before, is that we don't clear in the software. I assume that that's actually somewhat... That's actually okay, because there shouldn't be any empty space anyway. But I do wonder whether we thought we were clearing or not. So in render.cpp, I'm actually wondering clear. So like this is the clear, but it doesn't necessarily sort to the back, is the thing. So that might be a problem. The clear, like, I don't know. Oh, but it should. So I don't know why that's not working. But it's not. Let's take a quick look. I'm just curious. Render commands to bitmap. Render commands to bitmap. So intersect base cliprect with cliprect. See what we got. Can we please step into... Wait, that's not... Why am I there? That's not what I want. I want to be here. There we go. I don't want to watch every thread. Just want to watch one thread. Is that so wrong? Oh, Visual Studio. Fine. You don't want to show me more threads? I mean, you want to show me all your threads? I will kill those threads, and then what are you going to do about it? Not much. Not much, my friend. Actually, that'll probably still create one extra thread, won't it? That's unfortunate. Maybe I should have set that to 0. Yeah. So what I really should have done is this. Does that work? There we go. So now, why aren't we clearing our screen? Here's the clear call. We come in here. We're doing some stuff. We get our fill rect out. 480 by 720, that's certainly a screen. What's our color value? Where's the alpha value? What? Color's a V4, right? So why does it only have... Oh, there it is. The alpha value is 0. Well, who put in a clear color of 0? So is this operator error? Did we put in the wrong clear color? Because that ain't no good. That ain't no good at all. I would like to just point out to you how not good that is. Is there a clear... Look at that. Look at this. So I guess that's technically okay, because if you're doing a clear, then the alpha value you're trying to set the destination alpha value to be something. So now that I think about it, that's actually right. So probably the way that we need to do this is this should really force set that color, you know, like this for now. That's not perfect, but that's really the problem, right? Oops. So now we should be okay. Yeah, there we go. So yeah, and then of course, you know, if I actually did want to see how fast, while we're here, let's see how fast it is. Let's just take a look. All right. So here's the hardware renderer that's running through OpenGL, and here is the software renderer. So quite good, right? And I think, if I remember correctly, in our profile, a lot of that time is waiting for Windows to get off its butt. Yeah. Most of that time is we would actually be hitting 60 frames a second in the software render right now if Windows wasn't sitting around doing nothing. Although, you know, part of that's probably, we probably need to just use a P buffer to transfer the screen. So we could probably fix our OpenGL submission the way that we're actually downloading the software rendered bitmap to it. We can probably fix that. So that's, I mean, it's kind of our fault. Let's see. When z-axis is defined, will up-down hopping look different? I don't know how. I mean, it shouldn't probably look all that different, but we need to straighten out our z. It's always been a little wrong, and now we kind of know what it should be. We're gonna have to go in and fuss with that a little. Lumenian, what are limitations of game development using C#? I mean, there's tons of them, right? It's a garbage collected language. It's runs through an interpreter. I mean, it's like, you know, so you don't really know what it's got to be just in time compiled if it's going to be optimized. Like, it's a pretty high level language, so there's limitations everywhere. The limitation is you can never actually control what the CPU is actually doing. There's a huge stack of stuff in between you and it. And so do I like it as an overall language? No. I hate languages that put a lot of stuff between me and the computer. That's Bamboo. What parts of C++ are you using if you are not programming in an OOP style? We use function overloading, operator overloading, and sometimes constructor-destructor pairs for like block scoping. I think that's mostly it. Clemensbaum, I'm currently using a Microsoft Natural Ergonomic 4000, thinking about replacing it with a non-ergonomic keyboard. Any thoughts? I always have trouble with those ergonometric keyboards. The Microsoft Natural one, especially the spacebar, drives me insane. It's so hard to push. So I prefer the non-ergonomic mechanical ones, which is not to say that I wouldn't prefer an ergonomic one if it was actually made by a sane human. But I swear the people who design natural ergonomic keyboards don't type much. At least not from my experience. Let's see. Ingenero, how many A's will this game have when it's done? Do you mean like triple A? I don't know. Huber Caleb, the trees in the bottom row look like they are being clipped at the top. Also, C# is compiled these days to some extent. Well, I mean, it's always JITted, or can be JITted, depending on the circumstance. But it is not compiled. Well, it is not. Technically, if you compile to bytecode, it's still compiled. It does not produce machine code, right? That is. It does not produce machine code you can control. And the reason I say that is because, there's a garbage collector. You didn't write it. You have no idea when it's even running or how it's being built into your game. You have no idea how how most of that stuff actually is. It's got an entire sort of layer there. How the dynamic code stuff is done. You have no idea. You didn't write any of that, so it's whatever they did, And not only is it whatever they did, it can also be whatever that particular implementation of C# is, because it's not, like it's always going to be the same even. Is that a real clicky keyboard, or is it just sound effects? Yeah, this is an old DOS Keyboard 3. As for the trees being clipped off the top, I thought we looked at that, and I can't remember. I think it's just because we require one apron's worth of pixels. Remember, these art assets aren't built with the way that we ended up deciding to do the render. They were just some stand-in stuff that we used. So I believe that that's part of it, although, to be honest, it may be also just part of the art asset. GIMP? Any GIMP in here? And Innoville, I have not seen Swift. Chrono Dragon, how come I have to declare a political party in order to vote in the presidential primary? So the reason that you have to, I happen to know that Chrono Dragon is in Washington State, so I can answer that question. Otherwise, I wouldn't necessarily be able to have to ask where he lived. The reason that you have to declare a political party to vote in a presidential primary is because I believe the Washington State Supreme Court, I believe it was the Washington State Supreme Court. I don't know if it was federal court. Hold on one second, let me answer this question. Yeah, so you can see, so the reason it looks like they're clipped is because it actually does end like that, and this part right here is actually in the 1 pixel apron, which we don't render. So remember, all art assets in the actual final game have to be packed with that 1 pixel apron, and these art assets aren't packed. So if we actually added the 1 pixel apron, we'd be fine. So hopefully that answers the question. So originally in Washington State, you did not have to declare a political party to vote in the primary. You could simply vote in whatever primary you wanted to. Unfortunately, that was ruled against by the court. I don't remember the name of the case. I'm sorry, it's been a while. And so after that court ruling, they needed to, they were required to revise their primary system in Washington State, and now you have to declare a political party in order to participate in that primary. But, the why in the grander sense, then it was a court case, I you know, I mean, I don't know the cosmic why, but that's the procedural why, if that makes sense. And if you want to look at the specifics of that court case, you could find out, for example, what the exact ruling was in terms of why the old system was not allowed to continue, and get a little bit more insight into it. I usually only pay attention to federal Supreme Court cases. State Supreme Court cases, if this even was one of those, I don't even know if this case went to the Supreme Court. It probably did. I suspect it was a state Supreme Court case, because primaries are would generally not be federal, would not be a federal thing. So I'm assuming that that case opinion would give you the information you wanted, and I don't read those opinions, so I don't know. Oh, and yeah, this thing right here is blinking. I agree with that. I assume that's because this and this are like coincident, and so they sort randomly, but I'm not sure. All right, I'm going to wind down. I'm going to wind it on down. And yeah. Save that off. Thank you everyone for joining me for today's episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home with the source code, you can always go to handmadehero.org and pre-order it, the game rather, and it comes with the source code so that as we develop the game, you can play around with it at home and practice the sort of stuff that we cover on the stream. We also have a forum site, which has now been upgraded thanks to the folks at Handmade Network. So if you go to that site, and this link, they switched the link around on me, so I'm going to go change it now so it'll point to the right place, as I talked about earlier in the stream. You can now go there, and the forums are a lot more pleasant to use. We also have a Patreon page if you want to support the video series, a schedule bot who tweets the schedule at you if you wanted to catch the series live. And we have a episode guide, which is maintained by our very own Miblo on the chat. Go there. You can also and catch up on past episodes. It's got great annotations. And while you're there, consider subscribing to his Patreon, because he annotates those episodes for the benefit of everyone, just out of the goodness of his heart. And so that is it for today. Tomorrow we'll be working on making that hop look a little bit more nicely animated and adding some more goodness to it, and sort of attaching that head on there. So we're just kind of building up in parts the quality of that, and as the quality improves, the feel will get nicer and nicer. So that's it. I hope to see you back here tomorrow, 5 p.m. Pacific Daylight Time. Until then, have fun programming it, and I'll see you guys on the internet. I'm going to go to the chat and figure out why the Zanbot, which I was supposed to use for Twitch, has kicked all of our better bots off, so I'm going to go make it so it doesn't do that anymore. Those of you who happen to know how that's working, please stay on the chat for a minute and I will come ask you. Okay, take it easy everyone.